Okay, so I'm going to talk about remote access. I'm going to talk about a game plan, marketing for how do we decide what we're actually going to do. And, you know, deciding what we're going to do, if we're comparing remote access solutions in terms of their features, well, that's easy. What features do we need? Get the features, off we go. If we're comparing remote access solutions by how secure they are and how secure do we need to be, well, those are more interesting questions. That's what I'm going to cover here. If you're interested on the Waterfall website, I don't know, 6 months ago, 8 months ago, send me an email. You'll have my email on the very last slide. Um, there was a webinar I did where I surveyed remote access technologies and explained how a lot of them worked. Because if you go on the websites, a lot of these vendors, they don't tell you how their stuff works. So I tried to figure it out and explain it. This presentation is a subset of that. I've taken a handful of different kinds of remote access solutions, technologies, and we're going to compare them by security. And we're going to, on the end, I'm going to look at some use cases. I'm going to look at applying the knowledge we have to different industries. I'm going to look at some, somewhat more advanced topics in the terms of risk management when we're looking at security and safety. Oh, and if I could ask people to go on mute, I hear a little bit of background noise, but thank you. So let's begin. Let's start with sort of the classic, what everyone understands. This, in a sense, is building your own VPN, or you're building your own remote access. You don't have to go out and buy this solution. You probably already have a corporate VPN. You probably already have a demilitarized zone, a network between networks, between your OT network and the IT network. You probably already have two-factor authentication on your corporate VPN. What you do is you put a jump host. If you can see my cursor here, um, you know, we've got a remote laptop coming in over the internet into the IT network, going through the IT OT firewall into the jump host. This is just a Windows box. You log into it. This is one user at a time. Again, this is build your own. One user at a time, log into the jump box, and the jump box is a machine that has permission to go through the firewall to OT hosts, to reach OT hosts, and do things to them, run tools on them, log into them, whatever. So this is build your own. Now we're going to compare the strength of about five solutions, including this first one, by how do you compare the strength, the security strength of different solutions? We look at attacks. We ask the question, what attacks does this solution defeat with a high degree of confidence? And the other solution not defeat with a high degree of confidence. The difference is the security difference. And so the way we evaluate security is attack. So I'm going to look at a half dozen attack scenarios. Now I'm going to come back to this slide. Let's go through the attack scenarios. What do people worry about? They worry about connectivity. If I come in through a VPN, I mean, there's lots of different VPN solutions out there. Um, but if I come in through a VPN, a lot of the time, it is as if I connected my laptop to the network that I'm connecting to. I just put a wire in. If I connect a wire to the network, what can I do? I can reach anything else on the switch I just plugged into. So a VPN, a virtual private network, a lot of the time, it's as if you plugged into the network. It lets you see whatever you want, which is a problem. Sometimes I want my remote vendors to come in and see only their machine, the one machine they're looking at, the one machine they're supposed to be maintaining, not all of the rest of my network. Because if there's anything nasty on the vendor's laptop, because the vendor was Googling something a minute ago and mistakenly downloaded a piece of malware and activated it, that malware can reach out through the VPN and touch anything it wants. So high connectivity is a problem. VPNs a lot of the time give us too much connectivity. So that's one kind of attack. Um, High risk features. If the bad guys take control of my remote laptop and they can paste, uh, a megabyte of attack software into the jump host. Well, now there's attack software on the jump host, and they can file transfer attack software into the OT network. Well, that's a problem too. A lot of these features are very convenient, but they're problems when we're talking about attack information entering an OT network. So high risk features are a problem. Um, Pivot. A pivot is where a bad guy takes over a computer, an asset, a firewall, something, takes over something with a CPU in it and uses that CPU to attack other systems. Okay, you use a compromised system to attack another system, you take it over. Now you can repeat. You use the newly compromised system to attack the systems it can see, and you can move around your network. You can find the firewall or the computers to take over that have permission to go through the firewalls. You can take over the firewalls themselves and use the compromised firewalls to reach deeper into the target network, the OT network. Um, Server pivot. So there's a couple of different pivot scenarios here. One is you take over the firewall and you're through. A second one is you take over a server behind the firewall, the remote access server, the thing that's giving you access. You take it over because you found a vulnerability, a 0-day. I mean, the firewall pivot scenario, the one that comes to mind is a couple of years ago, the Chinese intelligence found a 0-day in Fortinet VPN servers. Now, I am not criticizing Fortinet. I love Fortinet. They do really good stuff. But what they're selling is software. Any software potentially has 0-days in it. The bad guys found a 0-day and took over, I kid you not, 20,000 Fortinet VPN servers sitting on the internet and pivoted through them into the networks behind. So that's the firewall pivot. A server pivot is where you take over the remote access server and pivot through it into the OT network. Session hijacking is you've got a session in progress from the remote laptop into the OT network, and someone takes over the session and starts using the permissions of that session to attack the OT network. This is easiest to do with web-based remote access tools because 9 times out of 10 to take over the session, all you need to steal is the cookie, because that's how web servers keep track of connections, of sessions from one point to another. Because think about it, web servers. You might think I'm connected to the web server. No, you're not. 9 times out of 10, you pull the web page and you close the connection, and then you read the web page, and 3 minutes later you click on something and you open a new connection to the web server. How does the web server know that it's still you? It's the cookie. Same thing with remote access. Steal the cookie and you're in. And client pivoting is the bad guys take over my laptop. They own my laptop now. I don't know this. I log in through my laptop, and they can see the screen. They can move the mouse when I'm not watching it. It's a trickier attack because if I'm watching this, I'm going to see some of this stuff. But it's possible to take over the laptop before a session is set up, watch the session being set up, and then steal it. So these are all different attack scenarios we're going to evaluate every secure remote access solution against. And the last thing I have in there is what kind of remote access is it? Attended remote access is where you need someone in the OT system working with you on the outside to facilitate remote access. Unattended is where I can come in from the outside anytime I want and work my will upon the OT network without any assistance from anybody inside the OT networks. That's the difference, attended, unattended. So this is the comparison criteria. Let's go back to our scenario. Homegrown, I've got a jump host, I've got a VPN, I've got a firewall. Well, my VPN, if it's one of the kind that lets me touch everything, lets me touch everything. This is a problem with this kind of solution. This is why a lot of government agencies today say, please, please, please stop using VPNs as remote access tools. Use something stronger. Part of the problem is high connectivity. High risk, a lot. So, remote desktop. If I've got a VPN and I'm remote desktoping in, remote desktop lets me cut and paste a megabyte of stuff off of my clipboard. I can if I'm logged in through the firewall, sorry, through the VPN, I can start up a file transfer tool. I can drag and drop from my laptop into the jump host. This is, or into the DMZ. I can drag and drop malware onto any sort of share on the jump host. So yeah, these features are a problem in this roll your own scenario. Firewall pivot. Well, I'm sorry, if the firewall has a 0 day and I take it over, I can pivot through it. Yep, that's a problem with this. Server pivot. If the Windows host is not fully patched, or if I find a 0 day in Windows, but that's harder to do. If the Windows host is not fully patched, and for the record, if you have this, um, turn on automatic updates on your jump host. There is no reason not to update your jump host. Yeah, the jump host might blue screen. It will be annoying if the jump host blue screens, but 9 times out of 10, the jump host is not essential to 24/7 operation of the OT asset, is it? It's a convenience. Automatic update the jump host. Um, if you find a vulnerability in the jump host, you take it over through the VPN and you're in, and it's all gone. Rats. Hijacking the session. It's actually harder than it looks to hijack a remote desktop session. So I gave this a check mark. I said, this is not something that we're extremely vulnerable to here, because we're not using a web browser to access the remote access system. Client pivot, meaning take over the remote laptop. Yep, that's a risk. So there's a lot of risks here. This is a solution that, when we compare it to this set of attacks, has a lot of problems. And what kind of remote access is it? It's unattended. I can log in whenever I want. So I'm not going to spend this much time on all of the others, but I wanted to go through this one so you can see what's happening here. Now let's go through another 4 or 5 of these things. If you buy an OT secure remote access system, really it's a software system. I think of these things as software remote access, not secure remote access. What does secure mean? Secure remote access. Um, the Sorry, lost my train of thought. Um, are you secure right now where you're sitting, watching me? Sort of. Security is like safety. Are you safe right now, sitting where you're sitting, watching me? Yeah. Could you be safer? Yeah. Could you be less safe? You could be watching this while skydiving, couldn't you? Yeah. Safety is a spectrum. It's not yes or no. Security is also a spectrum. Saying I have secure communications does not mean my communications are invulnerable. There's no such thing. What does secure communication mean? It means I encrypted it. Well, how secure is that? Well, if I steal the key, it's all over. Right. So what does it mean to call it secure? It's not really secure, is it? Same thing for secure remote access. There's no such thing as secure remote access. So, I really don't like the name of this technology. And give me a moment. This has just reminded me that, right, here we are. Okay. So how does this work? Almost all the secure remote access out there um, is going through the cloud. Okay, the remote laptop connects to the cloud system. I mean, just like you're doing here. You didn't connect to my laptop, did you? I connected to GoToWebinar. You connected to GoToWebinar, and we rendezvoused. We connected in the cloud. GoToWebinar is connecting us, and you can see my screen because we rendezvoused in the cloud. This is how a lot of OT remote access works. I log into the remote access system. The industrial site has some software on a software remote access server, and it connects out to the cloud. And if you have the right credentials, the cloud says, oh, you can connect to each other, and your keystrokes and mouse go to this OT system. That's how these things work. How secure is this? Well, it takes away the problem of the VPN. There's no VPN anymore. I can connect to whatever systems the cloud lets me connect to, and nothing else. So that problem's gone away. I've got OT software remote access gets a check mark on that. High risk features. I'm sorry, the OT remote access ecosystem competes on features. They have features 9 ways to Sunday. They have all of the high risk features. So that's a problem. Firewall pivot, there's still a firewall in there. You break the firewall, you can get into the OT network. Oh, server pivot. The thing in the cloud is also software. It also has vulnerabilities. If the bad guys figure out one of these vulnerabilities and take over the server in the cloud, they can rendezvous whatever they want. They can take over whatever they want. It's a problem. Session hijack. Most of these OT secure remote access solutions have the option of a web-based user interface, which is, I'm sorry, steal the cookie. It's too easy to break. So that's a problem. And the client pivot, if you take over the laptop and while it logs into the OT solution, it's also a problem. This is still problematic on average. And what kind is it? It's unattended. Well, what else is there? Well, let's look at one of the things that's recommended in the latest CISA, American Computer and Information Security Administration. Their latest document they put out with a couple of other countries, and they said, if you're talking about high consequence OT systems, one of the things to consider is a time switch. What's that? Well, usually it's deployed with a unidirectional gateway. It's deployed in parallel with the unidirectional gateway. So give me a moment. I'm going to digress for a second, explain what a gateway is, and then I'm going to come back to this because it kind of makes sense to go together. A unidirectional gateway, the NIST 882 definition. Okay, this is not something I made up. This is something NIST, the National Institute of Standards and Technology in the USA, made up. The NIST definition is that a unidirectional gateway is a combination of hardware and software. The hardware is physically able to send information in only one direction. The software makes copies of servers. So how does the hardware work? Well, think 2 circuit boards under the hood. The circuit board on the left is connected to the circuit board on the right with a fiber optic cable, usually 18 inches long, bright orange. The board on the left has a laser in it, no receiver, no photocell, just a laser. And the circuit board on the right has a photocell, a receiver. So you can send from the circuit board on the left, from the industrial network, out to the IT network, but it's not physically possible to send anything back. There is no laser in the receiving circuit board. It can only send one way. Oh, tricky. How do you get that to work? That's where the software comes in. The software makes copies of servers. If we have an Oracle server, if we have a Pi server, if we have an OPC server, any kind of server in the industrial network that has the data that we need to push out to the world, to the vendors, to SAP, to our IT people, the software logs into the data source, OPC, Pi, Oracle, whatever it is, and asks for everything new, everything since we logged in a second ago. I mean, there's more complicated options, but I'm dumbing it down. This is the easy way to think of it. Think of logging in once a second and asking for everything new since we logged in a second ago. And you get back whatever, 3, 4, 8 megabytes of data. The software pushes the data through the weird one-way hardware. Nothing else in the world sees that hardware. It's only the gateway in software sees it internally, pushes it through the weird hardware. And on the other side, the software logs into an identical server. And if and inserts the data. It can be an OPC server, it can be a Pi server, it can be an Oracle server, it can be any server you need. So now we've synchronized the 2 servers. Anything on the outside, the enterprise historian wants data from the industrial OPC server. The enterprise historian can ask the enterprise OPC server for the data and gets the same answer as the live system would have given without ever sending any message back through the hardware. I mean, think about it. Cyber sabotage is what we're trying to prevent on the OT network. All cyber sabotage is information. The only way that a control system can change from a normal state to a compromised state is if attack information enters it somehow. And so if we cannot send any information through the hardware into the system, then we cannot send any attacks through the hardware into the system either. So once more, under the hood, just because I'm going to come back to this. Each unidirectional gateway, according to the NIST definition, has at least two CPUs associated with it, one on the inside and one on the outside, and has this other hardware, the one-way hardware associated. That's the heart of a unidirectional gateway. So let's come back to the switch. What we have here is a unidirectional gateway out, sending PI data, OPC data, whatever you need out. Anything that's allowed to be shared with the IT network is pushed out through the gateway. And nothing that corrupts the IT network can leak back through the gateway into OT. Well, how do we do remote access then? What we do is a timed switch. So if I am sitting on the outside and I need my VPN jump host remote access, I phone up the operator. The operator hangs up and calls me back and says, Andrew, did you just phone me? Yes, I did. What do you need? I need you to go to the server closet and take the key in the secure bypass unit and turn the key. And it activates the time switch. Normally, there's electromagnets in the switch. Nothing gets through the switch, zero. When it's activated, you've got a gigabit of bidirectional connectivity, and you can connect with your VPN into your jump host through all of your firewalls and software into the OT network. But most of the time, the switch is disconnected. And so I've got whatever the switch is programmed for, 30, 60, 90 minutes of access, and then automatically the switch pops back, a timed switch. So almost all of the time, nothing gets through. The gateway lets nothing through, the switch lets nothing through, no attack information can enter the OT network. But while I'm connected, I have unattended remote access. I call it minimally attended because the operator had to turn the switch. There has to be someone at the site who can turn the switch. If I'm calling a substation 1,000 kilometers away with nobody in it, this doesn't work. It has to be at an attended site. What about the risk? Well, you do have the risk of, in this scenario, a VPN coming in. You do have that high connectivity risk, but only while the switch is engaged. You do have high risk features, but only while the switch is engaged. You can pivot through the firewall, but the firewall is only exposed to attack while the switch is engaged. You see the pattern here. All of these threats exist only while the switch is engaged. So it is stronger than software. It's not impenetrable. Nothing is perfect, but it's stronger than software. You're only exposed for a few minutes at a time. Now, if you need somebody remoted in 8 hours a day, 7 days a week, this doesn't work. Or rather, it does work. It just doesn't buy you any security because you've got software exposed all the way through. But if you need infrequent access, this dramatically reduces the opportunity for the bad guys to attack us. Hardware enforced remote access. This is something new in the world. This is a pair of cooperating unidirectional gateways. Now you remember each gateway is two CPUs and the weird hardware. So what we have here is, let's call it the gateway on the bottom is sending screen images out, and the gateway on the top is sending encrypted keystroke and mouse in. And you might ask, well, why is that any more secure than software? Why even bother with all of this complexity? And the answer is it's more secure. This is why it's recommended by the latest CISA advice. How is it more secure? Well, imagine, take the Fortinet scenario. The bad guys, imagine they find a 0-day in the two, and again, there's 4 CPUs under the hood, 2 of them on the outside, 2 of them on the inside. Imagine the bad guys find 0-day vulnerabilities and exploit 0 days in both of the internet facing or the IT facing, the exposed CPUs. They take over both of the exposed CPUs. And what they want to do is pivot into OT and manipulate OT. Well, how do they do that? Well, the CPU on the outbound gateway that is sending screen images out is useless to them because it cannot send anything back through the hardware. The hardware won't let any attacks pivot back. That's okay, say the bad guys. Don't worry about that. I can take over. I've got the other CPU as well. It has the hardware that's allowing stuff in. So I'm going to send my SYN floods and my buffer overflows and my denial of service attacks and my ransomware. I'm going to send them all through the inbound hardware, and the hardware throws it all out. What? The hardware throws it all out. Explain this to me. The hardware is, there is hardware. There's ASICs on the circuit board. The ASICs look at the communications and they allow encrypted keystroke and mouse through, and they throw everything else out. Fine, say the bad guys. They're getting a little frustrated by this point. Fine, say the bad guys. Then what I have to do this a hard way. I have to hijack the session. Okay, I take the screen images. I'm going to fake the keystroke and mouse. I'm going to send fake keystroke and mouse in. I'm going to take over that session. I'm going to work my will upon the OT network. And here's the thing. The credentials that let you encrypt the keystroke and mouse, they live on the inside CPUs, not the outside CPU. So in order to break into the inside CPU and get into the OT network, they first have to break into the inside CPU. It's a chicken and egg problem. In order to fake the keystroke and mouse so that they can break into the OT network, they have to first break into the OT network and steal the credentials to fake the keystroke and mouse. It's a chicken and egg problem. So let's look through the scenarios. High connectivity, no. This is not a VPN. You don't have high connectivity issues. High risk features, no. The only thing that lets through is keystroke and mouse. Okay, there's no cut and paste. There's no file transfer. None of those. This kind of solution tends to be designed for security, and so they just don't have high risk features. Firewall pivot, there is no firewall. Do you see a firewall here? I don't see a firewall. Server pivot, well, if you take over the exposed CPUs in the Hera server, both of the exposed CPUs. We just went through that scenario. It doesn't help you. Well, what about session hijacking? Well, there's no web browser here. It's, the credentials are buried away in TPM modules, which are hardware modules in the source CPU and the destination CPU that keep the credentials out of memory, so they're much harder to steal. Client pivot, take over the remote client. Well, it's still theoretically possible to take over the remote laptop. It's hard to do because the designers here have used all of the, again, Hera type solutions tend to be designed to minimize attack surface. They use all of the best practices on the remote laptop, but it is still theoretically possible. And what kind of remote access is it? It's unattended. So this is something that is stronger than software remote access. It's not quite as strong as unidirectional remote screen view. This is my last technology. It's been around for 15, 18 years. Again, think unidirectional gateway, one way out, nothing back. Let the screen images out. You can send the screen images out, but no keystroke and mouse can get back in. The hardware lets nothing back in. And the gateway is the only connection in this scenario between the OT network and the IT network. So how do you do remote access? Well, you can see what's happening. What you have to do is get on the phone. You pick up the cell phone, you call the site, you say, I see that you got, you logged a problem with turbine number 3. Can we get on the vibration management workstation for turbine number 3? And someone on the inside says, yeah, and walks over to the workstation and turns on remote screen view, starts sending images of the screen out through the gateway. Vaguely like starting FaceTime on my iPhone and taking a picture of the screen and saying, you see the screen? The person on the outside says, yep, I can see it. Now they can move their mouse. They can't get back in through my iPhone. They can't get back in through the unidirectional gateway, but they can say, I see the error message. I think you've got a problem here in the system. Go to system diagnostics and they can see the mouse move. And they can say, no, that's communication diagnostics. 2 further down. Oh, there you go. That's system diagnostics. And they work together. But this is attended remote access. How secure is it? Well, there's no VPN. High connectivity is not an issue. High risk features send potential attack information into the network. Doesn't exist. All the information is being filtered through my brain on the inside. Firewall. There's no firewall to break. You can't break through a firewall. What if I break through the gateway? What if I take over the outside CPU on the gateway? Well, the hardware lets no attack information back in. Oh, well, that doesn't help you. You can't pivot through a gateway. What about pivoting through the server? There is no server. It's just a gateway. You can't pivot through it. Oh, what if I steal the session? Well, then I can see the screen, but I still can't attack the OT network. Well, what if I take over the remote laptop? Well, I can change what they see on the screen, but I still can't send attack information in. Oh, so this is arguably the strongest kind of remote access. It's immune to all of these attacks. The problem with it is that it is attended. You do need someone on the inside moving the mouse. And so it's useful again for infrequent remote access, not constant remote access. I mean, I work with some refineries. They have 70, 80, 100 people remoted into every refinery 8 hours a day so that they don't have to drive into the refinery. So that is not the scenario for remote screen view. Remote screen view is a scenario where you have vendors coming in infrequently to, I don't know, adjust equipment to maximize the time between service, predictive maintenance kind of functions. So add it all up. This is how we compare the strength of these security tools. Which one do we use? And why would we use it? Do we always pick the strongest? Well, no, the strongest is a little inconvenient, isn't it? Again, 800, 100 people remoting into a refinery. You need 100 people on the inside moving the mouse. That's not going to work. Okay, so we have to make a trade-off between security and business needs. Well, how do we do that? Um, well, one of the things, what is risk? Oh, and if we could all go on mute, please. I'm still hearing background. Unless somebody needs to ask me a question.
Hi, and there's a
Yeah.
question from our attendees. They are saying that could you please explain what the HERA is? HERA?
Oh, sure. Sorry. HERA is hardware enforced remote access. It's a technology that is described in a document that came out of CISA about a year ago called, I've got it on my last slide. I've got the document and you can Google the name, but it is again, a kind of remote access that has hardware in there that does the hardware filtering in addition to all of the software features. I hope that makes sense.
Yeah, thanks.
Okay. Thank you for that. Um, so when we look at risk, what is risk? A lot of people look at say risk is likelihood times impact. Likelihood is problematic. Likelihood works when we have statistics. You know, the plant went down 6 times last year because of ransomware. Oh, that's bad. That's a problem. We have statistics. We can calculate the likelihood of it going down this week. If we don't have statistics and we have high consequence, what do we do? I'm going to talk about what we do, but a lot of people say that's okay. I don't have high consequence. Um, when we look at risk, the first thing we have to understand is how much trouble are we in? What is the worst, the very worst that can happen? And if every CPU in the OT network, every one of them, does exactly the wrong thing, tells the physical process exactly the wrong thing at exactly the wrong time, what's the worst that can happen? A lot of time, it's things blow up and people die. People are aware of this. They're aware of safety risks. A lot of times people don't take into account other risks. So this is something when we're doing the risk assessment, yes, think about safety, but also think about these blind spots. Equipment damage. If I misoperate a turbine in just the right way, it tears itself apart. A 300 megawatt turbine will take between 9 and 18 months to replace. These things are custom built. There is no inventory of 300 megawatt turbines I can bring in. And if it's torn itself apart, it's destroyed. You can't repair it. Oh, if I have an air conditioning unit in a high rise and I run it at full speed, absolute flat out, for a whole weekend, I destroy it. How? I'm running it faster than the water can move. Okay, these things have a range of speeds. I run at full speed, and you wind up with tiny vacuum pockets behind the blades because they're moving water around to cool things off. And these vacuum pockets collapse and send out shock waves through the water. Water is a very good conductor of shock waves. These shock waves, you run this thing for a weekend. It's a noisy process, but there may be nobody in the building for the weekend. And the shock waves, the constant shock waves destroy the unit. Well, now you've got to replace a large air conditioning unit if you want people to be able to come into the building Monday morning. So equipment damage is something a lot of people don't think about. Um, Safety instrumented systems. Everyone says, oh yeah, safety, safety, we got that covered. Right, but you got it covered with safety instrumented systems, don't you? Yeah, and that's software, isn't it? Yeah, and you can misconfigure software, can't you? And it might have vulnerabilities you can exploit. So it's software, protective relays that prevent damage, mostly to electrical equipment. These relays are also software with vulnerabilities. Think about the vulnerabilities. Bricked equipment is something a lot of people don't think about. They say, "Oh, I've got, I got this figured out. I got my protection systems in place. My equipment's not going to get damaged." What if the bad guys get into the OT network and log into each one of our PLCs and erase the firmware? What do you mean? Write zeros into the flash that is the firmware, and then they reboot the device, or worse, put the device into a loop that constantly writes zeros into the flash. The flash burns out after about 1,000 writes. Now, it's not just that you can't boot the device, it's that the hardware is burned out. You can't even if you take the device apart and look at the hardware and try and stick firmware back onto it, you got to replace the flash chip. What if they burn out 80% of the PLCs in our facility? Do we have spares for 80% of the PLCs? Most of us don't. They have, most of us have 10 to 20% spares. Um, what if they pivot through the cloud? A lot of us are connected to cloud systems. They take over the cloud, they pivot through the cloud into our networks, and they work their will upon our networks. Not just one of our sites, all of our sites, because they pivot because all of our sites are connected to the same poorly secured cloud service. These are all things we have to keep in mind when we're asking the question, risk, is remote access safe for me? Um, This is from the Waterfall, the latest threat report. The URL is on the bottom. You guys will have a PDF of this, so you'll have that URL. The threat environment changed dramatically about 5 years ago. The report looks at deliberate attacks, not errors and omissions, not mistakes, not equipment failures, deliberate attacks that caused physical consequences. Okay, not stole some information, not could have shut things down but didn't, actually caused physical consequences. Most often either equipment damage or shutdowns. So deliberate attacks, physical consequences, in heavy industry and critical industrial infrastructure. These are the industries we track. In the public record, no confidential disclosures. So we know this is an underestimate of what's out there because I've had confidential disclosures that I was not able to put into these numbers. For a decade, nothing happened. This bounced around between 0 and 5. I mean, 2010, um, that criteria in 2010, how how many attacks were there with physical consequences in heavy industry in 2010? There was one. It was Stuxnet. How many were there in 2011? There was zero. Well, this is when Havocs and Dragonfly were flying around compromising pharmaceuticals, and yeah, but they didn't shut anything down. They just stole information. Oh, for a decade it was flat, and then it changed, and most of the change is ransomware. But looking at what attacks are credible, for the decade, there were attacks on safety systems. That's a credible threat. That's something we have to think about coming after us in the future because it's happened in the past. You know, Equipment's been bricked, especially in the most recent attacks in the Ukraine. Look at the most recent threat report. The entire data set, by the way, is in the appendix of the threat report if you want to look at it. Substation gear has been attacked. Lights have been turned off. This was again in Ukraine. They tried to destroy the transformers and failed because they mistyped the IP address. They didn't store the IP address. Big endian, little endian thing tripped them up in the IP address. Nation state attacks tripled last year over previous years. So these are all arguably credible threats. Whatever's happened in the past is credible in the future for someone. Is it credible for us? I keep using that word credible. What does it mean? Well, the latest thinking in terms of risk is that likelihood is a poor estimate of what's going on for high consequence risk. For high frequency, low consequence risk, it's a good estimate. For low frequency, high consequence events, think these blind spots. Frequency, likelihood, well, it's low likelihood. Well, what should we do with low likelihood? Well, nobody really knows. And so a better way to think about it is credible. is, look at the set of possible attacks. I've shown you some possible attacks. I've got another white paper out there, top 20 attacks on industrial control systems, lots of different kinds of attacks. Look at each of the attacks and ask the question, is this a credible threat for me? If so, why? If not, why not? And then look at your credible threats and ask which of these credible threats could bring about serious consequences. So it's a smaller. Now you look at the set of attacks that are credible and could bring about serious consequences. And you ask, is it reasonable to be exposed this way, or should I increase the strength of my security posture to take these credible threats off the table? Again, instead of one risk matrix that we see in traditional thinking, what a lot of people are talking about today is two risk matrices, one for high frequency, low impact events that you can buy insurance for, and a different way of looking at high consequence threats. And design basis threat is the line between what we defeat reliably and what we don't defeat reliably. That's how design basis threat is defined. The question is, do we have any credible threats above the design basis threat? If we do, what are we going to do about them? Are we going to sign off on that and accept $1 billion potential liability? Who's going to sign on that? Or are we going to strengthen our security program, raise the DBT to encompass the credible threats? This is the modern way of looking at this. So let's apply this to a handful of industries, and then I'll wrap up. Nuclear generation. What is the worst case? It's a
And here we
catastrophe.
have a question.
Oh, yes.
We have a question. Someone is asking, do we need to consider scalability, constraint, protocol compatibility, human error, hardware manufacturing issues, and finally, probably a false sense of security for this?
Short answer is yes, you have to consider all of that. The question is, compare all of that to your defensive posture and ask which of these scenarios can get through our defensive posture and bring about a consequence. And, again, if the consequence is acceptable, if it's something we can buy insurance for, what do? We secure the system the way the insurer needs to make sure if we suffer the consequence, the insurer will pay us back. If the consequence is unacceptable, as a rule, you cannot buy insurance for it. High-speed passenger trains collide, hundreds of people die, mass casualty event. Can you buy insurance for that? I'm not aware of any insurance company in the world that will sell you that. They used to sell that. You know, 10 years ago, you used to be able to buy 5 billion US dollars of insurance coverage for general damages. Any damage you suffer, you get paid back up to $5 billion. Today, all of those policies have a caveat saying cyber is excluded. You used to be able to buy 5 billion, $10 billion of general liability. Anybody sues you for any reason, you're covered. You can't anymore. They all have cyber exclusions. If you want cyber coverage, you have to buy specific cyber coverage. And in most places, they won't sell you. They simply will not sell you any more than about $200 or $300 million worth of cyber coverage because the risk is too great. And so if we can't buy insurance, we either accept the risk, we sign off on $1 billion liability. Who signs that? Or we have to do something to raise the bar, to increase the design basis threat. So yes, all threats are on the table. The question is, are they credible? Is it reasonable to believe this will happen to us? And do we defeat them? And what is the consequence? And is it acceptable? These are the decision criteria. What's out there? Will it defeat us? Is that reasonable? And if not, what are we going to do about it? That's the decision process for all threats. But we're talking about remote access here. Let's look at remote access specifically in the nuclear generation case. Um, let's talk about the difference real quick between a disaster and a catastrophe. A disaster is where a hurricane comes in and the local governors of the local provinces or states, three of them declare a state of emergency, and the federal authorities come in, the army comes in and helps out with recovery. That's a disaster. You declare a state of disaster and it stays in place for, a week or a month or 6 weeks. That's a disaster. A catastrophe is where, for example, hundreds of square kilometers of land become uninhabitable for centuries. This was the Chernobyl incident. That's a catastrophe. With nuclear generation, you risk catastrophe if The automation has taken over. Okay. Um, what's a credible threat? One credible threat I worry about is three armed men with submachine guns and hand grenades breaking into my home, putting a gun to my head, and saying, Andrew, log into the nuclear plant now. Putting a gun to my kid's head and saying, Andrew, log in now. If that is a credible threat, then I don't believe we can put any remote access in place. And I'm not aware of any nuclear generator in the world that has remote access. And I think it's for exactly this reason. They don't tell me their thinking. It's classified half the time. But I think this is a factor. If this is a credible threat, it does not matter if you have 100.0% secure remote access. If this is a credible threat, you cannot enable remote access because you risk catastrophe. Oh, okay. Let's look at something a little closer to home. More conventional generation. What's the worst case? Probably that the lights go out for 18 months because the bad guys get in and destroy the transformers and destroy the turbines. Oh, um, what's a credible threat? What's reasonable to believe will attack us? The latest is living off the land. They steal credentials. They come in. They look like any other user. We have hundreds of users in these plants, and they just sit there waiting for the time where their bang going to, cause the damage. They're extremely difficult to detect. They're in these plants for years. That sounds bad. What are credible consequences? Here's where experts disagree. They say living off the land is possible, and then they argue about, is a 1 week outage credible? Is it reasonable to believe? Is it an 18-month outage with damaged turbines credible? Is it reasonable to believe? They argue. So you've got to talk to your stakeholders and argue out what are credible consequences. Today, practically speaking, what we see in conventional power plants, we're talking coal or natural gas power plants, um, what we see either is software remote access or unidirectional remote screen view. That's what we see today. Hera, hardware enforced remote access, that weird, screen images out, keystroke in, hardware filtering, that is newer, and we don't see it widely deployed yet, but we do see a lot of power plants looking hard at it because they want something stronger than software. Even if they're not willing, to give up remote access entirely, they want something stronger than software. So, and I'm going to go through the next few really quickly because they're just like generation. It's heavy industry. I'll come back to renewables in a moment. Give me a moment. Refining. What's the worst case? Things blow up, people die. What's a credible threat? Living off the land is also a credible threat for refining. What are credible consequences? The experts disagree. What is everyone doing today? They're doing software remote access. Some of them are doing unidirectional remote screen view, but it's not the majority. What's happening in the future? Most of the people who are doing software remote access are looking hard at Hera. And even some of the people who are doing unidirectional remote access are saying, can we afford to relax our security posture just a little bit to get unattended remote access in the form of Hera? So Hera is coming for refining. It's coming for pipelines. Exactly the same scenario here. But let me come back to renewable generation. It's a little different. What's the worst case? You brick the PLCs, you erase them, or you get long-term damage to the turbines, which are the blades and the equipment that generates the power as the blades turn. Um, that's your risk. Sorry, your worst case impact. What's a credible impact? Well, living off the land is another uh, credible scenario here. Remote control attacks, pivoting attacks are credible scenarios. Um, oh, I see a question here. Okay, um, let's finish the job here. Um, most of them today are doing soft remote access, but the thing is they need nearly constant remote access because, if you got 300 wind turbines, instead of logging in once a quarter to manage a large steam turbine, you're logging in once a quarter for each of the 300 turbines, wind turbines. That's a lot of logins. In fact, the renewables are not quite as mature technology wise as conventional. And so you probably don't have one vendor logging in once a quarter per turbine. You got three or four, sometimes six vendors per turbine logging in once a quarter. That's constant remote access. These people are really keen on moving to Hera because they see remote access as their Achilles heel. They see remote access as a serious problem. And manufacturing is the same thing. In most cases, the consequences, actually, manufacturing is a different thing. Manufacturing spans a huge spectrum, but most of manufacturing, the high end manufacturing is a different animal. We're talking building aircraft, we're talking, you know, uh, pharmaceuticals, human consumables, different animal. But most of manufacturing is small factories, small shoe factories, small bakeries. What's the worst? Well, maybe a little equipment damage is possible. Maybe it's not. What's a credible threat? Well, why would a nation state why would living off the land go after a small shoe factory? It doesn't make any sense. So, the consequence is lower. The credible threats are lower. Credible consequences, well, a lot of the time the factory is designed so it's really hard to damage anything and it's really hard to kill anyone. So your consequences, the credible consequences, tend to be acceptable. What's manufacturing do now? They use software remote access. Are they going to use something stronger? They're going to continue using remote access. They don't see the risks as that serious. They might switch to Hera because it's a little bit stronger, but it's less convenient because they can't file transfer and do all the stuff they like to do today. Some of them might move to Hera, but it's not a big push like it is in pipelines and conventional generation. So these are some examples of using the concepts of consequence and credible threats applied to the remote access world. A word about Waterfall. I work for Waterfall. We have offices all over the world. We are deployed all over the world, primarily in heavy industry and critical industrial infrastructure. We're trusted by heavy industry and critical industrial infrastructures all over the world. That's what I had for you. So to sum up, you know, secure remote access, there's no such thing. Um, Ask what attacks do you care about? What attacks do you regard as credible threats? We have to understand attacks. Okay, defenders have to understand attacks. It's not just penetration testers have to understand them. Defenders have to understand them as well. We do not all need to become a pen tester. I'm not a pen tester, but I do understand in principle how these attacks work. I understand the idea behind these attacks so that I can apply those ideas to my defenses. So um, compare attack scenarios and ask what are credible threats. And the bad news is every year that goes by, more and more things become credible threats. So keep aware of the attack environment out there because we have to defend against it. The great debate that's going on is what are credible threats? What are acceptable consequences? What are unacceptable consequences? Can I detect things in time to prevent unacceptable consequences? Or, could it be that the attack is going to be faster than I can detect it? Because I haven't even talked about intrusion detection and that part of the NIST cybersecurity framework. You look at the whole thing and you ask, how exposed am I? And that's the big debate. But now hopefully you've got enough information to start, contributing to the debate, to frame the debate properly. And what's new in the world is hardware enforced remote access. A lot of people are talking about it. This is the document that came out about a year ago from authorities in United States, Canada, and New Zealand saying, please stop using VPNs, use stronger stuff. They describe a bunch of web-based stronger stuff or cloud-based stronger stuff for IT networks. And they say for high consequence OT networks, you should be using the hardware enforced stuff, time switches, remote screen view, and the new hardware enforced remote access. That's what I have for you. I hope it's useful. My email is here. Reach out to me if you wish. Connect with me on LinkedIn. And if we have questions, I think I have a little time. Ooh, I'm running out of time. Let me take one question. Where's my questions?
Yes, we have questions. You can go into the question answer box and filter them to by your name. I have signed them to you.
I'm struggling to find the question and answer box. I had it earlier.
It's at the top right corner.
There it is. Oh, holy smokes, there's a lot of questions.
Yes.
What's the difference between a diode and Hera? The diode in NIST terms is the hardware, one-way hardware, nothing back. Hera is the combination of diodes and software and filtering. The hardware filtering is not part of a standard diode. Um, can you ever accept a vendor remote access solution? Yes, of course. I talked about the manufacturing. A small shoe factory probably only needs software remote access. It doesn't need uh, the stronger hardware stuff that you need for high consequence installations. Um, you know, view on remote access in high speed trains, nothing gets into the switching system. I think there's all sorts of credible threats that could get into the. Now, I disagree with other experts. Experts disagree, but nothing gets into the switching system. Switching systems deserve 62443 SL4 protection. They deserve unidirectional gateways. They deserve every kind of protection you can imagine. Remote access into a switching system, that just doesn't seem reasonable. Remote access into a network that could pivot into the switching system, that's also a problem. I think when we're talking high consequence, we need to be really cautious. But again, other experts disagree. You should get some different expert opinions. Um, what else do we have here? If likelihood cannot be determined, how is risk calculated? This is the topic of 2 or 3 chapters in my new book. I'm working on it. But think on the very high end, when you talk safety, you need a frequency of activation of your analog safeties. You can make an estimate. The estimate can range orders of magnitude. So you can, that the very high end of safety calculations, you can make up some numbers for it. Those numbers generally don't work when you're doing an ROI calculation. Frequency numbers do work on the very low end of the spectrum where you can make ROI calculations. It's the middle part of the spectrum that gets confused. And this is where credibility is coming in. This is where we ask a different question. Instead of asking how likely is it, we ask, is it a credible threat? Do we defeat it with a high degree of confidence? And if not, what consequences are we exposed to and who's going to sign for that liability? It's a different set of questions we ask in the middle. I think I've run out of time. Um, if you
Yeah.
folks can maybe cut and paste these questions and send them to me, I can try and answer them by email.
Yeah.
What
Thank you
What
so
do you
much,
think?
Andrew. I will send it to you, or you can either wait while Mike is talking and you can answer them directly. But if you
Oh, I'll try.
prefer,
Yeah, I'll try
I will.
that.
Yeah. Yeah. Thank you, Andrew. Now I would like to hand over to Rakesh for a quick intro about ICE, and then we can move on to our next speaker, Mike Holcomb.
Yeah, great. So I thought let me steal a minute from you and quickly talk about ICE, Institute of Cybersecurity Excellence. What is it? Because I got some question from people, what is ICE? So I thought let me add something here. ICE is a community-centric platform for cybersecurity education and training in operation technology. At ICE, we believe the best way to keep our critical infrastructure safe is by spreading knowledge and expertise openly and broadly. That's why we make many training programs, workshops, webinar, and certification accessible to everyone, strengthening the collective cybersecurity readiness of our cyber community. What we do in ICE, hands-on experience, comprehensive cybersecurity training, global recognized certifications, flexible learnings, formats, and expert-led sessions. So with this, I'll hand over to Mimuna.
Thank you, Rakesh. And we have another session. Who, Mike? Can you hear me? Hi, Mike. Can you hear me?
Hi, Monica. Can you hear me?
Yeah, perfect.
Great.
Thank you, Mike, for joining us. And I would like to hand over to you as well. So we are like 2 minutes ahead of time. So please, it's over to you.
All right. Thanks. I appreciate that. So, and hi, everybody. I appreciate everybody for coming and taking the time. What we're actually going to, I always forget, go to webinars a little weird. Uh, let me pull up some slides, and then we'll actually do some hands-on as well. So it's not just for slides themselves. But I appreciate the again the time for everybody for being here. Um, this presentation is kind of a combination of a couple that I've done over probably about the last year and a half or so in looking at how we can use tools like ChatGPT or other GenAI platforms to write tools to help us do our jobs as defenders, and whether that's looking at it from a defensive perspective, purely defensive, or if we're looking at it from a offensive perspective. When we start thinking of penetration testing in OT or ICS environments, I always talk about how one of the best ways to learn to become a defender in any type of environment is to learn how to attack it. So I really feel that people need to understand or learn how to attack OT, ICS environments to really become um, the best defenders that they can be. And that's what we're going to talk about in this presentation. So everything we're going to talk about, this is me, myself, and I. It's all for informational, educational purposes only. Everything we talk about, it's designed to be used for the forces of good, not for evil. So again, we're talking about how to compromise or break in or ultimately have an impact in some type of OT environment. And so it's again teaching this for the purposes of good and not evil. So, for those of you that don't know me, my name is Mike Holcomb. I am the fellow for cybersecurity at Fluor. If you're not familiar with Fluor, I had no idea what we did when I went to work there. Um, but we are one of the world's largest engineering and construction companies. There are probably about 10 companies around the world our size, and we build and design and engineer some of the world's largest OT or ICS control system environments. We actually just had my biggest project, our biggest project, and it was Shell's biggest project, go live, fully commissioned about a month ago, which is a $50 billion LNG port facility for Canada. So Canada now exports liquid natural gas, which is not something that they had been able to do previously. So it's really exciting to see a massive project like that that takes 6, 7, 8 years to come to fruition. And I did a lot of the cybersecurity design for that project. So we did start B-Sides ICS this year. I also read B-Sides Greenville locally. I have a ton of certifications and my master's degree from the SANS Institute for Control Systems. And then some of you might know me from my post on LinkedIn or YouTube, where I help people either learn about OT cybersecurity and get into the field, or for owners and operators that already are running a plant, right, that want to learn, right, well, what do we do for cybersecurity, right? Where do we start with OT cybersecurity? Or maybe they have a fairly well established program, but they also need to know, well, where do we go to next? And those are the things that I focus on. So I used to not show picture. Here's some of the projects that I've actually been on. Some of the world's largest power plants, bridges. Andrew was just talking about rail. We have a couple of rail projects in some of the largest cities, especially in the United States. And at the bottom, that's the LNG port facility for Shell. So again, if we're not connected on LinkedIn, definitely reach out. Love to have everybody there. Um, there's I do post every day, so you'll find plenty of content out there and lots of resources. So just jumping in, when I was doing my master's for SANS and had to come up with a project, right, for the thesis slash white paper. But I also wanted to make it hands-on, and I really wanted to demonstrate how PLCs are very vulnerable. If you're not familiar with what a PLC is, it's the most common control system that we have. It's a programmable logic controller, very similar to if you think of a thermostat for an air conditioning or heating unit, that it's a computer sometimes I get in trouble. Engineers hate it when I say that, but it's a computer. Right? It has an operating system, has firmware. Uh, Not a lot because it doesn't store like massive spreadsheets like our Windows systems. Um, but right, it's a physical computer or system that is hardwired into other physical systems out in the real world, like the air conditioning unit. So that way, if the room becomes too warm, the thermostat, right, detects that, right, and it sends a electrical signal to turn on the air conditioning unit. And then it continually takes the temperature in the room with a sensor, so that way it knows when, oh, okay, the room's back to where we want it to be for desired temperature, and sends another signal to turn off the air conditioning unit. Right? That's a control system, and that's the idea of what a PLC can do. And so I had a conversation with a gentleman who ran one of the largest OT cybersecurity programs in the world. And he told me, well, that's a PLC, it's not vulnerable. And I was still pretty new to the field at the time. This goes back like 10 plus years. And I was like, well, maybe he's right. I'm like, am I, driving myself crazy thinking? Because I'm like, but no, you can attack them in all these different ways. And at the same time, I'm like, well, he's the guy, right? He runs this huge program for this huge company. I'm like, I must be wrong. And then I took 30 seconds to look up a vulnerability advisory for a PLC, and I was like, no, he just has no clue as to what he's talking about. And sometimes that happens with leadership positions. Sometimes. So I really wanted to highlight that PLCs are very unsecure for many reasons, and just for awareness and education. Because obviously, there's a lot of people out there that think they don't have security problems. And so, my whole idea was to come up with a platform that you could, let's say you have a manufacturing facility, that you would have this platform like a web interface that allow you to see all of the PLCs in your environment, and then whether they're in run mode or not. And what that means is each PLC has what they call different operational modes. More simple ones typically have run mode, so it's up and running and we don't have any issues. I think that thermostat, right, is bringing in temperatures. If it gets too hot, it turns the air conditioning on. When it's normal, when we're back within a specified temperature or what we call a set point, we turn off the air conditioner, right? That's run mode. If we needed to do maintenance or if we needed to upload firmware to that PLC, we would take it out of run mode and put it in sometimes stop mode, program mode. It can be called different things, and there are many other modes. But in general, from a cybersecurity perspective, the idea is people see run mode as being more secure than others. So if I'm in run mode, people think of it as like read only. So a remote attacker couldn't make a change to that PLC. And that's kind of true, but it's not always true either. It'll probably prevent you from uploading firmware to the PLC if you're in run mode the vast majority of the time. And I had tested when I did my master's thesis, I had 6 of the more common types of PLCs that you'll see in the world. And so for all of those, you couldn't upload firmware if it was in run mode, but it would allow you to upload PLC logic. So the programming of the PLC itself. And we're going to actually look at a live example of this when we get to the end of the presentation, which I pull from my penetration testing for OT and ICS course. So the idea though was I was going to create this GUI, right, to be able to look at all the PLCs and tell me if they're in run mode or not. The idea being if something comes out of run mode, I need to investigate to determine, right, is it maybe a technician making a change, right? It could be completely legitimate. Right? Ideally, we should see that in an approved change window. Or if not, well, what's happening, right? Is it maybe the system's failing, right? Or what if some type of an attack, right? For what it, no matter what the reason is, we need to investigate, right? So we get a little flag to say, hey, we're no longer in run mode for this Schneider PLC sitting over in the packaging area. You need to go investigate. And so I finally got the advisory team to sign off on, yes, you can do this for your thesis. And I thought, awesome. And then I realized, oh, like I have to create a web interface to do this, and I have to figure out how I can remotely determine if a PLC is in run mode or not. And not just one PLC, but all of these PLCs. And then I realized, I'm like, well, I'm not a developer. I've pretended to be a developer many times over the years. Um, and I guess I should give myself more credit. Like I can do it, but I just don't have the patience, and I admit that. When I get error messages, and I'm like, no, I don't want to deal with it. So for those of you that do, more power to you. I really admire you. I just don't have the patience to do it. And I remember though getting this approval, excited. It was a very long process, and I had just been reading, because this goes back, probably almost 2 years at this point, that attackers were using GenAI to write phishing platforms. I was like, well, if they can use ChatGPT to write a phishing platform, well, surely I could use ChatGPT to create something like this. And yeah, this literally was like 15 minutes for just the web interface. I was like, whew, that's a, big concern or big worry I had because at the time, right, I figured it was going to take a long time. So, and then it actually didn't take too long to figure out how to determine if the PLCs were in run mode or not either remotely. So thankfully, I had all these pieces. I just had to put them together. So since then, in building this tool, I've built a lot of other tools. I think a lot of people are just like me, and I could be wrong, but at least some of you probably, at some points in time, and maybe you're not a developer, but you always think of it'd be really cool if I had this tool to do this, or it'd be really cool if I had a tool to do that. And so we can use ChatGPT to be able to create those tools. And it does a really good job in a fairly short order. And so we're going to walk through kind of some ideas on how to get you started using ChatGPT or other Gen AI to create some security tools. And then we'll look at some projects, and then we'll actually look at some of the simulated OT environments that I've built, especially for the pen testing course, where you can use them to learn how to launch attacks against OT systems, but also more importantly, how to defend against them as well. And so when you first start using ChatGPT, and if you've never used ChatGPT or GenAI before, I know there's still some folks out there that haven't. Right, here's where I just say, hey, I'm going to tell it, hey, write a Python script that's going to print hello friend on the screen. Right, every programming class always starts with hello world. I like hello friend, which was from the original pilot for Mr. Robot, the TV show, which was a play off of Hello World. For me, I thought it was a much better fit. Right. The really cool thing is, all the platforms are very similar, right? It comes back and says, hey, here's your script. Of course, this is just one line, right? It even explains this is what the script does, and even tells you how to run it if you don't actually know how to run it, or if you've never done anything like that before, which is really cool. And you can even click the little copy code button. So that way you can just save it out to your script and run it. And then, it says, hello, friend, which is really nice. And the nice thing with ChatGPT or the others is when you're building little programs, it does help to go step by step. Like tell it to do one thing, test it out, make sure it works, and then add another feature. Test it out, make sure it works, and add another feature. Now, this is an example of where I actually said, hey, I want you to write a script, and it does a couple of things. And it actually worked. So I actually said, hey, I want to create a basic port scanner. So like Nmap, but I don't, in this case, right, we don't want to Nmap. Maybe I'm in an environment where I can't even download Nmap. And so I just want a tool to be able to test for these 5 different ports. You see, I'm going to test for ports 80 and 443, so for web services. And we see those a lot on OT assets as well these days. And then we see some OT protocols like S7, which runs on TCP 102, Modbus, which runs on 502. We're going to talk a lot more about Modbus later, and Ethernet IP, which is 44,018. Right? So it's like Rockwell devices. And S7 is for Siemens, and Modbus we see on pretty much just about everything because it's open source. And it's not associated with a particular vendor. But the idea is we're going to create this port scanner just to see if any of these ports are open. And so ChatGPT comes back, right? It says, here's your script. I run it, right? In this case, I run it against my Wi-Fi access point at home. And you see, yeah, it shows, oh, TCP 443 is open, right? So probably some web administrative interface, right? That's one of the reasons why we look for that port. And then I can run it against a PLC that I have. And you can see in this case, it says, oh, okay, TCP 502 is open, which means more than likely, right, that's going to be Modbus, right? So we have a PLC sitting there. So we found, again, it's just a very simple port scanner just to test those few ports, right? So nothing fancy, right? When we start thinking of, okay, well, what if I am an attacker, right? The scripts we've already talked about, well, these are Python scripts, right? If I got into an OT environment, remember, most OT environments we have OT assets like PLCs and uh, Andrew was talking about safety controllers, SIS earlier, when we talk about uh, HMIs, DCS, right? Besides those control systems, everything else, usually most environments that I see, it's all Windows machines. And yeah, you might have a little Linux and little oddball systems, sprinkled in there, but you have Windows everywhere. And so when you think about it from an attacker or a defender perspective, right? If I got into the OT network, most Windows don't come with Python to do that in the OT network, or I might trip off a signal that would tell the defenders that I'm in the environment if I'm an attacker. And so that's where we get into, well, living off the land. And Andrew touched on this a little bit earlier, because the Russian adversaries did get into another power generation facility in the Ukraine in, I think it was 2022. And they didn't create ICS specific malware, right? They didn't take, which costs millions of dollars and take 6 to 12 to 18 months to develop. They just went from Windows machine to Windows machine to Windows machine until they found a web interface to log into their control systems. It was a SCADA manager interface, web interface, where they logged in with really basically simple to guess password and got went into the interface and turned off all the breakers for the power to create a blackout. And then to make sure that you couldn't easily restore the power, which is very typical in Russian format, they wiped all the machines. And so when you think about it, that attacks don't have to be that complicated in the OT world to have an impact. And I don't have to write ICS specific malware like Stuxnet back from 2010. We can talk about, and we will, malware like Frosty Goop, which, yeah, you can recreate in ChatGPT in 5 minutes or less. And that was used by the Russians not to create a blackout, but they turned off the heating in 600 apartment buildings, not apartments, but apartment buildings in Ukraine in the middle of winter, sub-zero temperatures outside. And it took them 2 days to figure out what the heck was going on before they could restore the heat. So when we talk about looking at it from an attacker perspective, right? Well, if I get into a Windows environment, I don't want to install Python. Again, I might not have the option. I don't want to, give the defenders an idea that I'm in the environment, right? Again, we're thinking of this from an attacker and a defender perspective at the same time. So what we can do is, well, every Windows machine runs PowerShell. So I'm going to go ahead and I'm just going to tell ChatGPT, hey, take this Python script and convert it over to PowerShell. And the really cool thing that I found here was not that it converted it from Python to PowerShell, but when it created the PowerShell script and I ran it, well, I got this error message. And like I talked about earlier, right, for me, I'm pretty much done at this point. Again, I have no patience for this because I look at this and I just see blah, 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 blah. And then it's like, and then so I literally, I remember closing the screen, walking around, I went into the kitchen. I think I started making dinner. And then I was making dinner, and then I realized, you know what? I wonder if I can take the error message and paste it into ChatGPT and if it'll figure out what's going on, right? It's supposed to be AI, right? And I did. And it actually came back and said, hey, you know what? I made this mistake when I was converting it from Python. Uh, I fixed it for you. Here's the new script. Go ahead and run it. And I did, and boom, now I have a PowerShell script that does the same thing as the scanner in Python, but now I can run it on Windows without actually having to install Python. And so here you can see, and the output looks a little bit different, but it's the same result, right? So we can see, oh, that, yeah, Modbus is open, right? TCP 502 is open on that PLC IP address. So again, really, if you get anything out of this presentation, ChatGPT is awesome at troubleshooting error messages. I do it a lot also on Linux machines, right? If you ever try to install something or you're trying to maybe using like Kali Linux and pen testing, if you get an error message, just put it in ChatGPT and it'll help you figure out what the problem is. So you start to get this idea, right, that we can write all these different types of tools. Again, I think the port scanner is just a simple example to show not only can we create a tool that can be used for good and bad, right? So it's good and evil, but at the same time, right, we can do things like, oh, convert it to PowerShell. So we can go more living off the land. We don't have to install Python on machines. We can write tools and we really are just limited by our own minds, right? So I've had a lot of fun, like as time permits. It's not like I have a ton of time, but as time permits to come back and create little projects. Again, all my time over the last couple of months has really been focused in the OT pen testing course and building out the scenarios and the simulated environments and the different tools because I've just had so much fun with that. But it all started here because one of the projects I had goes back to a lot of control system environments. They do a horrible job at asset management. Right? And this is true for large environments, small environments, and everywhere in between. And a lot of people think, oh, it's just an asset inventory, right? It's not a big deal, but it is. Without an asset register, you can't do things effectively like incident response or vulnerability management. And I could tell you horror stories of especially large environments that fail down in those areas just because they don't have an asset inventory or what we call asset register. But a lot of environments do seem to have a bunch of PCAPs running around. Usually it's from some troubleshooting once upon a time. And so I said, well, I'm going to see if we can just create a simple script that would read a PCAP, right, a packet capture, take out all the IP addresses, and then take out the MAC addresses for each of those IP addresses. And then with that MAC address, if you're not aware, the first half of the MAC address actually is assigned to a specific company or vendor. So if you take those MAC addresses and do the reverse lookup, you can actually see who the vendor is of that system. It's like, wow, that's awesome. And so it can help you start to build that asset register. So here it builds out the script for us. It does say, hey, we're going to use some additional modules for Python for additional functionality, right? Awesome, right? Tells us how to install them on the system. And then when we run it, I got this screen. It says enter the path to the PCAP file. And I said, oh no, I'm not doing that. Like if it's on a Linux box, you're just used to typing paths. Like I totally get that. But on a Windows machine, it's like C colon backslash blah 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 space blah 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 space. That gets really ugly really fast. So went back and said, hey, you know what? Take the script you just wrote, add a graphical interface for allowing me to select the PCAP file. And literally 30 seconds or less, when you run the script, it's like, okay, the first thing you see is, oh, yeah, find the PCAP. It even has the little filter set, so it's only showing PCAP files. And then, of course, PCAP NG if you wanted for the newer formats, right? But you could select the file, and then it goes through, strips out the IP address, the MAC addresses, does the reverse lookup, and then puts it all in an Excel spreadsheet. And then you basically have this kind of very simple asset register. And sure, we still need to fill out the PLC name or the model firmware location. And of course, it might not even be a PLC. So I guess I was assuming something there. But you get the idea. And this is really helpful for different organizations because I think a lot of people forget, and this especially for people that do like sales and marketing in the OT world, they forget that the vast majority of OT organizations out there, they have very little money, right? They have very few resources. They're not going to go out and buy the latest, greatest shiny tool or solution, even the ones that have been around forever. They just don't have the money. They never will. And so the more we can do, right, and to help them do their job more effective, the better, right? Because it's the only way they're going to become secure. And there's only so many, like I work with the Shells and the Ramcos and the BPs in my day job, right? And these enormous environments that they invest heavily and have some of the more mature OT cybersecurity programs in the world, or none. But when I do consulting, especially outside of my day job, I go into environments that they don't have a ton of resources. Or when I talk with folks on LinkedIn or they ping me, through YouTube or send me an email, they work in an environment. Again, they'll never have any resources or money related to OT cybersecurity, at least not for the next couple of years. So what do, right? How do you help these folks? So again, ChatGPT is a great way to be able to create all these tools to help us be more secure today than we were yesterday. And it doesn't really cost anything. You can use ChatGPT and some of the others for free. And so, I must have hit the wrong button, sorry. So another project I really liked and had fun with was, when I look at OT, and we always talk about the number one way to protect OT environments is to put a firewall between IT and OT. And this came from conversations with state adversaries. Of course, I'm talking with American state adversaries, and they usually don't give you open-ended answers, but they won't even talk usually, but they'll kind of shake their head, one way or up and down or side to side to give you an idea. Because I've always just been fascinated with kind of, it's part of the spy world, right? But it's also a world I work and live in. And so I was always curious, like, well, what's like the one thing we can do, right, to protect OT environments? And Rob Lee at Dragos, he always talks about this, right? You just need a firewall between IT and OT. And a lot of people forget Rob was actually a state adversary and an attacker, besides all of his defensive work that he did. And it's really, really true. And then unfortunately, even a lot of environments, again, I see a lot of environments that if you would actually look at the firewall, right? It's not, I always talk about it's not really a firewall, it's a dumpster fire or dumpster firewall. Because if you actually looked at how the firewall is configured, it's pretty much usually wide open, or it has really big security holes that an attacker could slip through from IT, or that ransomware or some other type of automated malware can move from IT into OT really quickly. Now, I hate sometimes having this conversation because a lot of people take this and use it to foster this environment of, oh, it's IT versus OT, and we can never have that. The OT teams and the IT teams have to work together to protect the environment. If we don't, the attackers are going to win. So I'm not trying to get into the IT versus OT. It's IT and OT working together. And at the end of the day, I don't care who, right, configured the firewall, other than we have to make sure that it's configured securely, right? We have to configure it correctly to keep the attackers out. Now, even in environments that say they have the firewall, or maybe a layer of firewalls between IT and OT with an IT OT DMZ, that's awesome. But one thing they're failing to do is actually watch the traffic on the firewall. I've actually been in environments where I have found, different types of attackers, including state adversaries, just by watching firewall traffic. I kid you not. And looking at the differences between not only what's allowed, but what's actually denied. Sometimes it's a lot easier to find out, what's going on in the environment by looking for the denied traffic. And so again, nobody's watching the firewalls typically. I mean, there's some environments that might have a SOC, and sometimes even the SOC, it might be pulling in that firewall data, but they're not really looking at it. And so in this case, there's like a sample Cisco firewall log. I can have ChatGPT look at this. Now, I can upload it, right, if I have no resources and I'm in an environment where we don't consider this information sensitive, right? If we ever consider that information sensitive, we never want to upload it to ChatGPT or another platform. In this case, this is actually Gemini. And you would actually just create a script to do that review locally, right? And I've done it both ways. But in this case, right, we're in a simple environment. The boss has signed off on the fact that none of this information is considered sensitive. Just upload it to ChatGPT or Gemini and be done. Gemini makes much prettier graphs and pictures. And so what it's really looking for, and it's why I like giving all the prompts, but it's that we can say what traffic is allowed between IT and OT, right? So in this case, we can see things like, oh, SQL Server. So that could be data historian traffic, right? And this is, you can see it's OT to IT. So from OT to IT, right? From the plant to the back office, not the other way around, right? We see some SSH connectivity. It's like, I probably would investigate that. Should that be allowed? And I see HTTPS. Like, should that be allowed? Yeah, probably not. Maybe the data historian traffic would be legit. The others, someone's probably trying to get away with something. And it's probably not an attacker necessarily, but right, you need to look into it. Like I mentioned earlier, you can learn a lot by actually looking at denied traffic as well. Here's traffic from IT to OT. So what's coming from IT trying to get into OT? So we see things like SSH, Telnet, HTTP, HTTPS, right? SQL, but coming from IT into OT, right? Completely different direction, different implications. But again, we can investigate, see, well, where's this SSH coming from? Where's this Telnet coming from, right? Is it just an overzealous, tech on the IT network, or maybe is it somebody sitting there running Nessus or Nmat, right? We see that a lot, right? That would generate a lot of denied traffic, and that would indicate that, hey, the firewall is actually configured to block that traffic, which is good, right? Which is great, actually. But then some of these like might not have a legitimate, kind of reasonable explanation. Then maybe it is an attacker in the environment. and they're trying to get into the OT network from IT. Now, I'm a big fan of free tools, and ChatGPT goes a long ways just for free and not having to log in, which is really cool. I mean, I have a paid account, but again, I like to promote things that are free. So Gemini, it timed out really quickly. I think I ran like 5 prompts and it was pretty much done. So I was like, okay, I guess I guess we're done there. I went to try Claude, right? And this idea that it's the privacy first AI. And I was like, well, this is really cool. We could try that. And then the they don't actually even allow you to use it for free without logging in, which I thought was really ironic since it was the privacy first AI. So I was like, it was so ironic. I'm like, I just can't do it. So yeah, you can use ChatGPT and you can use Gemini for free without logging in. Right. So I decided I go back to ChatGPT and create a chart of block traffic. And in this case, it was looking through a firewall log. And if you look, it sees block traffic on port 1, 689, 676, 677, 678, 679. So more than likely, this would indicate there's some type of port scan. More than likely, right? Some type of port scan going on in the environment. And then what I really want to be looking for, right, is out of this firewall traffic, do I have anything in the OT network connecting with the internet? Right? And that's really easy to look at. In this case, it's a public IP address, and I defamed it, but that was associated with Full Typhoon like a year and a half ago. Because in most OT environments, we shouldn't see connectivity out to the internet. If we do, more than likely, it's going to indicate, yeah, that either, well, somebody's remotely accessing our resources, right? This goes back to what Andrew was talking about earlier. Somebody from over the internet is accessing the OT network. Now, are they legitimate users or are they attackers or both? Because I've gone into environments where you see both, and you don't want either of them there, honestly. So that's just another example. So I know we have a little bit more time. So I actually want to show you a couple of the resources I had to put together for my OT pen test. And all of these also appear on LinkedIn and YouTube. The pen test course, actually, the first 2 parts are already up on YouTube. So I like to do the courses for free from time to time, and I do them like pay what you can, so people can come for free. You don't actually have to pay. Um, but again, I had a lot of fun putting these together um, using, again, ChatGPT. I'm not a developer, right? But then I started realizing it's like, well, I've been doing like all these little projects. Like, could I use it to create a simulated environment? But a realistic simulated environment. I don't want, something that kind of looks real. And it's like, no, it needs to look real, feel real, and for all intents and purposes, yeah, be real. And so you see, I have a lot of scripts I've created. This is just like probably the first couple of hours of the course. I might have got carried away a little bit. Um, and it's really interesting because I created this one simulated environment, and we used it for the CTF for the ICS Village at DEF CON this year, which was really fun, and a couple other things. But I had created this little simulation of essentially it looks like a thermostat, right? The idea was it would be something very familiar to people. I realize, of course, this is Fahrenheit, so more of a U.S. centric thermostat. But the idea, and then actually some gentleman had taken it and then built it out even further because he works for a company that makes sensors for OT environments, and so he built it out with additional settings and make it even more realistic. So this is actually like this one screen, this is what I created. He then went back and created all of these other tabs, which was really impressive. And he used ChatGPT to do it. So which was great. The idea though is again from the learning perspective, right? I think a lot of people I know for myself, right? When I first trying to learn OT and ICS, I had really no idea how these things worked. And there wasn't a lot of information out there. In some ways, there's still not a lot of information today about OT and ICS cybersecurity. I think one of the things I like to highlight is, let's say if I am an attacker and I find this would be considered that HMI, the the human machine interface, or the GUI, right, that allows us to see what's going on in the environment. And the idea is that in this case, I see it and I think, oh yeah, it's a thermostat for an air conditioner unit. But you don't know, right? Is that air conditioning in somebody's home? Is it an air conditioning unit in an office building? Because that's going to be a bigger unit. Or what if it's like I have one client in my side consulting that I do that they're manufacturing and they have to keep they're in this massive facility, right? Super, super cool. And they have massive air conditioners. They're the size of my house. They're bigger than my house. So as an attacker, if I just got onto an OT network and I just saw this, I wouldn't know whether it's a small little air conditioner for an apartment or a house, or is it a massive air conditioning unit the size of a house, like for a mega data center or a manufacturing site. I wouldn't know. And in some ways, it doesn't matter from an attacker perspective because I'm going to compromise it. I'm going to attack it. I'm going to exploit it the same way. And that's what you start to see in OT and attacking OT is the same principles we use for attacking this thermostat, no matter the size of the air conditioner, are can be used to attack that power plant. Like Andrew was talking about the turbines. Like, what if I could access the system to impact how that turbine operates? Maybe I can drive it and I can make it overheat, or I can slowly break it down over time. Right? Those are some of the scenarios that we actually go through in the course. I actually just finished the tool to do brute forcing, which can definitely be used to break mechanical systems down over time. So we have the simulated environment, and then we can walk through a scenario. So let me open up another command prompt. I'll change to my scripts directory. And then I'm going to run. I have a couple. Again, I get a little crazy, but I think part of it is to help folks that are learning kind of take it step by step, right? So there's some initial scripts that they might only do like one thing, or there's a script that does three things, or now, right, there's this one script I call the Swiss Army knife. Oops, yeah, we have to give it an IP address. In this case, I'm just running it locally so you can see everything on the screen. So that way, I can just hide this in the background because that's kind of distracting. That, all right, we have our simulated environment, and this simulates not only an HMI, but there's a PLC on the back end, right, controlling that air conditioning unit. And then we have now a tool where I can be able to connect to the system. And you can see it does more than a few things. Now, one of the things when I first start looking at this, right, and I want to, ultimately, let's say we have a goal, right? We want to have some impact in the environment. A lot of times in OT, we say we want an impact, right? We want something to blow up, right? Or we want to break down the system over time. In this case, right, we're just going to use a simple example. I want to turn the air conditioner off, right? Because we can see it's running and it would essentially run 24/7. We want to turn it off, at least, until a human operator interferes. Right? And so if I'm looking at this, there's a couple of things that I first would start looking at. I kind of want to understand what type of system it is. So the tool actually has the ability to issue some commands to gather more information about the type of asset it is. So in this case, you can see it simulates a Rockwell PLC. Right here's the product or the model number. Here's the firmware version running on it. So we can use that to determine, are there any software vulnerabilities in that PLC? There probably are. And then when I start looking at, okay, well, if my goal is to turn off the air conditioning unit, one thing we can start to look at is we can read the values running on the PLC that's physically wired into the unit, right? Because remember that the controller, right, it monitors and controls what's going on in the environment, right? It has a sensor that's continually bringing in the temperature, and that's going to become important in a moment. But I can start doing things by doing things like reading coils. So PLCs store data. We talk about Modbus. We store data in coils and registers. Coils are binary data, zeros and ones. That's it. Registers are anything from 0 to 65,535. Right? So if I read the coils inside that system, right? And I can say, hey, show me the first 10. And this is where there's this weird thing in the script because it actually shows you like 16. I don't know why it does that. But if I can read the coils and I see, remember, I'm only going to see zeros or ones. And here I see a bunch of zeros, and then I see, ooh, the fourth coil, number 3, right? It's zero-based numbering, which I hate, but it is. It is what it is. So the fourth coil, that's a 1. So I might think that, and this works in some control systems, does that 1 indicate whether the air conditioner is on or not? And in this case, we'll just cut to the chase. It does. And so it's like, oh, well, what if I overwrite that value and I change it to 0? Would that turn off the air conditioner? And we're able to do all this because Modbus is unauthenticated. It never asked me for a username and password. It's basically so I have essentially full control over that PLC. Now, it doesn't allow me to do anything I want with it right away because remember, there's that logic, there's that programming running inside the PLC. And we don't know necessarily unless we actually find the code itself or the project files how it actually works. So we're going to kind of work through it over the next couple minutes. Because I'm going to go ahead and, okay, well, let me write to that fourth value and change it to 0. So I'm going to change the 1 to the 0. Again, that represents whether the air conditioner is on or not. And if you watch the air conditioner, sometimes you could see it turn off just real briefly. Most of the time you don't, right? You never actually saw a change. So we actually turned it off, but it turned itself right back on because the PLC has programming that says, hey, if the current temperature is higher than the set point temperature, the air conditioner is on. And so, yeah, even though if we say, oh, turn the air conditioner off, it just literally turns itself back on, or it never even physically had time to shut down. Now, if you screw with that timing and do it kind of a little slower, you can get it to turn itself on and on and off like super fast. And that's where you can get things to break down, right? So again, we see the set point temp, right? We want it to be 72 degrees. We see the room temperature is actually higher, it's 75, and you can see it fluctuates between 74 and 75 degrees, but it's still higher. So the air conditioner should always be running. Okay, well then, well, I might say, well, what if I take the current temperature and I make that lower than the set point? Well, that would turn the heater off. So the temperatures, right, those are values higher than 0 and 1. So those aren't stored in coils, they're stored in registers. So we can read the registers. In this case, when you say, show me the first 10, it actually gives you the first 10. And now I can see, oh, look, yeah, register 4, number 4, right, has a value of 72. I see that in the HMI on the screen. And I see register 6, right, has a value of 74. Oh, and I see that on the screen. So we can understand real quickly, because this makes it really easy when we can see the HMI and the values on the back end, because we know, oh, I can change number 4 or number 6 to change the temperature. So let's go ahead and we're going to change, right? We're going to change the register. We're going to change number 6. So instead of 74 degrees, let's go ahead and make it 60. And if you watch the screen, we can see 65 changes to 60, and the air conditioner did turn off for a split second, but then it turned back on. Because what we forgot about was that that PLC has a sensor that's continually checking what the temperature in the room is. And it's continually writing that value to that space in the register. So even though we say, oh, okay, it's 60 degrees, well, right after that, the sensor, right, takes the temperature and writes it, and it overwrites our value. So that's not going to be a way that we can permanently turn off the air conditioner, right? It's not going to work. It'll work for a split second, like we saw in that case. Depending on the timing, sometimes, again, you might not ever see the air conditioner going off because of the timing. So then our only other option here is, okay, well, what if we go ahead and overwrite it? So let's overwrite that 4th value and let's change it to something like, well, 80 degrees. So if the set point, right, the desired temperature is 80 degrees and it's 74 degrees in the room, then yeah, guess what? The air conditioner goes off. And what if I did this at 6 o'clock at night and there's nobody in the office and there's nothing to trigger an alarm? By the time the people come back in the morning, like if you're that client that I have in manufacturing, they go into where all their product is stored, they're wiped out. They have no product for the next 6 weeks. And for that one company, like especially the first year or two, they were in startup mode. If that happened while they're in startup mode, they would have closed their doors and they never would have existed any longer. And now they do really cool things in different industries like automotive, and they work with some of the biggest players in the world. But if somebody had just come in and turned off their air conditioner and wiped out their product, which they could have done this way, that's why we need cybersecurity. But it's also why I like talking about OT pen testing, to show you it's not that hard. It's not that, and again, it's not that hard to turn off an air conditioning unit. Again, whether it's for my house or for this manufacturing plant or a mega data center, or create a blackout in a power plant. Or how about preventing clean water from getting out to the public? Or how about stopping a train between train stations, between subway stops? A lot of times it's not that hard, and you can follow just these basics. And so that's a big part of why I really like this demonstration. Hopefully it hits home, because it is something hopefully you can recognize and then start to understand. A lot of it, it's just like IT attacks, right? We're taking advantage of people making mistakes. Developers make mistakes. Somebody had to program that control system, right? You can see there's a fuzz register, which just puts random numbers in all the registers. You can see we just turned the set point to 80, 8100 degrees. Should you be able to do that? No, of course not. But the programmer didn't think about it. And do you want to think, well, what else did the programmer not think about? Did they catch every little thing from a safety perspective? Probably not. Probably not. So I appreciate the time. I know we have a couple minutes for questions, and if you have a question, you can always reach out to me on LinkedIn or YouTube. I do highlight, and I mentioned this earlier, Frosty Goop, which was that piece of ICS malware that the Russians used to turn off heating in those 600 apartment buildings. You can recreate that in ChatGPT in 30 seconds or less. Actually, one of my YouTube videos does it, and we actually do it in the OT pen test courses as well. But I would say, yes, keep in mind that Gen AI, right, it only gets better every day, right? Sure, it's the worst it's ever going to be is today, right? Because tomorrow is better, and it's better the day after that. And just remember, we're not just using it, the attackers are. In fact, the attackers are probably using it more and more effectively, I hate to say. So again, I appreciate everybody for taking the time. If you have questions, definitely, I think we have a few minutes here, but always, reach out and connect with me on LinkedIn. You can find the training schedule at mikeholcomb.com if you're interested in taking the courses. Again, they're pay what you can. You can also come for free. So I'd love to see some other folks there. The first time I did day one, we had 1,000 people take it, which was just insane. So especially part two this time is going to be a really big course, but those are always fun. So again, I
Thank you so
appreciate
much,
it.
Mike. We have so many
Thank you.
questions at the Q&A box. If you could address them while we have some times, and then I can send it to you, or people can directly message you the questions.
Sure. Yeah. Sorry. Yeah, I couldn't see anything while I was sharing the screen. So let's see. Let's see.
There is a Q&A box at the top right corner.
Here it is. Yeah, so reading PLC information version number and user identified info is defined as information disclosure vector in CISA. How do we secure Modbus TCP to prevent such vectors from prime attackers to exploit the system? You can't. The only thing you can do is you can prevent attackers from connecting to the system to make those requests. That's the only thing you can do. You can't make changes to Modbus because of its nature, right? By nature, it's unauthenticated. Sure, there's newer versions that people are working on to do things like authentication and encryption, but for the current Modbus version that you see everywhere, and I see it everywhere, you can't. If somebody's on the network and they can connect to it, they can do whatever they want with that system. So yeah, you have to keep the attacker off the network. And that goes back to kind of where we're talking about things like the firewall, right? Having that firewall between IT and OT and making sure that you're not allowing attackers into the environment. So um, they were exploring the idea of deploying OT-specific honeypots to generate real-world intelligence from a risk and practicality perspective. How effective are honeypots in detecting novel ICS SCADA attacks? There's a lot there. One thing I will say, so I do actually create a lot of honeypots with ChatGPT for OT. And I'm actually going to release like a formal one that people can use because I laugh when OT honeypot vendors call me because I'm like, I don't need to spend $20,000 with you. I'm sorry. Because a honeypot doesn't have to be anything special. Now, when you talk about novel attacks, uh, again, that's like a whole what do you consider novel um, in systems that have existed for 30 plus years? I don't necessarily know if there's too many like novel different attack types. Um, so a honeypot just needs to be very simple, right? To see if somebody connects to it, and you have an attacker in your environment. If this is something that you're going to put out on the internet and you want to see what people are doing to poke and prod at it, that would be a whole other story. But if you really are just using for honeypots for defense, it can be super simple. You deploy it internally, somebody hits it, hey, we have an attacker in the environment, so we need to investigate. So hopefully that helps with that one. So I guess
Thank you,
probably
Mike.
don't have any
Please could
more
you?
time, but
Yeah, no worries. We are